The red sands of Mars have long captured our imagination, but the journey to reach them is far more than a dream. It's a challenge that could redefine humanity's place in the universe. What if I told you that the key to unlocking this next frontier isn't just in the hands of astronauts, but in the precision and ingenuity of robots, from autonomous rovers scouting alien terrain to advanced AI systems solving problems no human could tackle alone? Robotics are quietly revolutionizing how we explore space. These mechanical pioneers are not just tools, they're the bridge between Earth and the stars, making the impossible possible. So why should we care? Because the future of human spaceflight, and perhaps even our survival, hinges on the technologies we're developing today. Let's take a closer look at how robotics are paving the way for humanity's journey to Mars and beyond, and why this isn't just science fiction, but the next chapter of our story. Imagine trying to repair a satellite in the vacuum of space, or navigate the jagged, uneven terrain of Mars without ever setting foot there. These are the kinds of challenges robotics are designed to tackle, and they're doing it with remarkable precision. Take the Mars rovers. For instance, Curiosity and Perseverance are more than just machines. They're robotic explorers, meticulously designed to withstand the harsh conditions of the red planet. They analyze rocks, measure atmospheric conditions, and even search for signs of past life, all while sending back data that helps scientists piece together the story of Mars. These rovers are like our remote hands and eyes, allowing us to explore a world millions of miles away as if we were there ourselves. But it's not just about Mars. On the International Space Station, robotic arms like Canadarm2 are performing tasks that would be incredibly risky for astronauts. They handle delicate operations, such as moving heavy equipment, assisting with spacewalks, and even capturing incoming spacecraft. These robotic systems are built to operate in the unforgiving environment of space, where a single mistake could have catastrophic consequences. By taking on these high-stakes tasks, they not only protect human lives, but also expand our capabilities, enabling us to conduct experiments and maintain equipment that would otherwise be impossible. What makes robotics so indispensable is their ability to adapt and problem-solve in real time. Equipped with advanced AI, these machines can analyze their surroundings, make decisions, and even learn from their experiences. This isn't just about following pre-programmed instructions. It's about creating systems that can think and act independently in unpredictable environments. Whether it's navigating treacherous terrain or troubleshooting a malfunction, robotics are proving to be more than just tools. They're reliable partners in our quest to explore the cosmos. And let's not forget the bigger picture. Robotics are paving the way for human missions to Mars and beyond. By sending robots first, we can gather critical data, test technologies, and scout out potential landing sites, reducing the risks for future astronauts. They're laying the groundwork for humanity's next giant leap, proving that the future of space exploration isn't just about humans or robots, it's about the powerful synergy between the two. This collaboration is what will ultimately allow us to push the boundaries of what's possible, turning the dream of interplanetary exploration into reality. Picture this, a robot alone on a distant planet, navigating a landscape that no human has ever seen. It's not science fiction, it's the reality of autonomous rovers like NAS, our Perseverance. These mechanical explorers are the ultimate pioneers, venturing into the unknown with a combination of cutting-edge technology and sheer ingenuity. Armed with advanced sensors, high-resolution cameras, and powerful AI, they're not just rolling across the Martian surface, they're actively analyzing it, piece by piece, searching for clues that could rewrite our understanding of the universe. What makes these rovers so remarkable is their ability to think for themselves in an environment where communication with Earth takes minutes, if not hours. They're not just following a set of instructions, they're making real-time decisions, avoiding rocks, cliffs, and other hazards that could spell disaster. This level of autonomy is crucial on a planet where every second counts, whether it's choosing the best path to a scientific target or deciding how to position a robotic arm for a soil sample. these machines are constantly adapting, learning, and problem-solving. And the data they collect is nothing short of revolutionary. By analyzing Martian soil, rocks, and even the atmosphere, rovers like Perseverance are helping scientists piece together the history of the red planet. Was Mars once home to liquid water? Could it have supported life, even in its simplest forms? These are the questions driving their missions. Every sample they gather, every image they capture, brings us closer to answering them. But the work of these rovers isn't just about understanding Mars. It's about preparing for the day when humans might walk its surface. By scouting the terrain, testing technologies, and mapping potential landing sites, they're laying the foundation for future human missions. Think of them as the ultimate scouts, paving the way for the next generation of explorers. Their discoveries are shaping not only our scientific knowledge, but also our plans for making Mars a new frontier for humanity. In many ways, these rovers are more than machines, they're extensions of our curiosity and determination. They remind us that exploration isn't just about reaching new places, it's about unlocking the mysteries of the cosmos, one discovery at a time. And as they continue their work on Mars, they're proving that the future of space exploration is as much about robotics as it is about human ambition. Together, they're writing the next chapter in our journey to the stars. Among the countless innovations propelling humanity into space, robotic arms stand out as some of the most versatile and indispensable tools ever created. Take the Canadarm2 on the International Space Station, for example. This marvel of engineering is more than just a mechanical limb. It's a precision instrument capable of performing tasks that would be incredibly challenging, if not impossible, for human hands alone. From assembling massive modules to capturing incoming spacecraft, these robotic arms are the unsung heroes of space infrastructure, ensuring that everything from experiments to repairs runs smoothly in the unforgiving environment of orbit. What makes these robotic arms so extraordinary is their ability to combine strength with precision. Picture a machine that can lift objects weighing thousands of pounds, yet handle delicate operations with the finesse of a surgeon. This dual capability is critical in space, where even the smallest mistake can have significant consequences. Whether it's maneuvering a solar panel into place or assisting astronauts during a spacewalk, robotic arms like the Canadarm2 are designed to perform with unwavering accuracy, making them essential partners for human crews. But their role isn't limited to the International Space Station. As we set our sights on Mars, robotic arms will become even more vital. Imagine a future mission where these mechanical limbs are tasked with constructing habitats on the Martian surface, deploying scientific equipment, or even repairing critical systems in harsh conditions. Their ability to work autonomously or under remote control makes them ideal for tasks that are too dangerous or time-consuming for astronauts. In a way, they're like the ultimate space handyman, capable of building, fixing, and maintaining the structures and tools we'll need to survive and thrive on another planet. One of the most exciting possibilities for robotic arms lies in their potential to assist astronauts during spacewalks. On Mars, where the environment is far harsher than anything we've encountered in low Earth orbit, these mechanical assistants could provide an extra layer of safety and efficiency. They could hold tools, stabilize structures, or even act as a physical bridge between astronauts and their work, allowing for more complex and ambitious projects to be undertaken. This synergy between human ingenuity and robotic precision could redefine what's possible in space exploration. What's truly remarkable about these robotic arms is how they embody the spirit of innovation. They're not just tools, they're extensions of human capability, designed to overcome the limitations of our biology and environment. As we prepare for the challenges of Mars and beyond, their role will only grow, proving that the future of space exploration isn't just about building bigger rockets or faster spacecraft. It's about creating the technologies that allow us to work smarter, safer, and more effectively in the vast, uncharted expanse of space. The true power of robotics in space exploration lies not just in their mechanical prowess, but in their ability to think, thanks to artificial intelligence and machine learning. These technologies are the brains behind the bots, transforming them from simple machines into intelligent explorers capable of making decisions on their own. Imagine a robot on Mars, millions of miles from Earth, analyzing a rock formation and deciding in real time whether it's worth investigating further. That's not science fiction, it's the reality of AI-driven robotics today. By processing vast amounts of data, recognizing patterns, and learning from their experiences, these robots are becoming indispensable partners in our quest to explore the cosmos. Take the Mars Rovers, for instance. Their AI systems are designed to identify interesting geological features, like unusual rock textures or mineral compositions, that could hint at the planet's past. What's remarkable is that these decisions aren't being made back on Earth. They're happening on the fly as the rovers navigate the Martian landscape. This level of autonomy is crucial when communication delays can take minutes or even hours. Without AI, every move would require input from mission control, slowing progress to a crawl. But with machine learning, these robots can analyze their surroundings, avoid hazards, and prioritize tasks, all while sending valuable data back to scientists. But AI isn't just about navigation or data collection, it's also about adaptability. Space is full of surprises, from sudden dust storms on Mars to unexpected equipment malfunctions. AI allows robots to respond to these challenges in real time, adjusting their strategies and even repairing themselves when necessary. For example, if a rover's wheel gets stuck in soft sand, its AI can analyze the situation, test different solutions, and attempt to free itself without waiting for human intervention. This kind of problem-solving ability is what sets modern robotics apart, making them more than just tools. They're active participants in the mission. As we look to the future, AI will play an even greater role in space exploration. Imagine a scenario where robots are sent ahead of human missions to prepare landing sites, construct habitats, or even mine resources. These tasks require not just physical capability, but also the ability to think and adapt in unpredictable environments. AI will enable robots to work alongside humans, complementing our strengths and compensating for our limitations. Whether it's analyzing data, performing repairs, or making split-second decisions, these intelligent machines will be essential to the success of our most ambitious missions. What's truly exciting is how AI is pushing the boundaries of what we thought was possible. By combining human ingenuity with machine intelligence, we're creating a new era of space exploration, one where robots aren't just following orders, but actively contributing to the mission. This synergy between humans and machines is what will allow us to venture deeper into space than ever before, unlocking new discoveries and redefining our understanding of the universe. And as AI continues to evolve, the possibilities for what these robots can achieve are truly limitless. Beyond the familiar boundaries of our solar system, robotic probes are rewriting the rules of exploration. These intrepid machines, like Voyager and New Horizons, have journeyed farther than any human-made object in history, venturing into the vast expanse of interstellar space. They're not just exploring, they're uncovering secrets about distant planets, moons, and cosmic phenomena that were once beyond our reach. Each piece of data they send back is like a puzzle piece, helping us build a clearer picture of the universe and our place within it. So, what exactly are these probes discovering, and how are they shaping the future of space exploration? Take Voyager, for example. Launched in the late 1970s, this iconic probe has traveled billions of miles, crossing the boundary of our solar system and entering the interstellar medium. Along the way, it's captured stunning images of Jupiter's swirling storms, Saturn's intricate rings, and the icy surfaces of Uranus and Neptune. But Voyager's contributions go far beyond photography. Its suite of scientific instruments has measured magnetic fields, detected cosmic rays, and analyzed the composition of planetary atmospheres, providing insights that have transformed our understanding of the outer solar system. Then there's New Horizons, which made history by flying past Pluto in 2015, revealing a world far more complex and dynamic than anyone had imagined. For the first time, we saw towering mountains of water ice, vast plains of frozen nitrogen, and a thin, hazy atmosphere. New Horizons didn't stop there. It later explored Arakoth, a distant object in the Kuiper belt, offering a glimpse into the primordial building blocks of our solar system. These discoveries are more than just fascinating, they're reshaping our theories about how planets form and evolve. What makes these probes so extraordinary is the technology they carry. Equipped with advanced cameras, spectrometers, and particle detectors, they're able to gather data that would be impossible to collect from Earth. For instance, they can measure the strength and direction of magnetic fields, providing clues about the internal structures of planets and moons. They can analyze the chemical makeup of atmospheres, revealing the presence of gases like methane, nitrogen, and even water vapor, and they can capture high-resolution images, allowing us to see distant worlds in unprecedented detail. But the impact of these probes goes beyond science. They're inspiring us to think bigger, to dream of what lies beyond the next horizon. Every image they send back, every piece of data they collect, reminds us that the universe is vast, mysterious, and full of wonders waiting to be discovered. They're not just tools of exploration, they're symbols of human curiosity and ingenuity, pushing the boundaries of what we thought was possible. As we look to the future, robotic probes will continue to play a crucial role in our exploration of the cosmos. Missions like Europa Clipper, set to launch in the coming years, will search for signs of life beneath the icy crust of Jupiter's moon Europa. Others, like the James Webb Space Telescope, will peer deeper into the universe than ever before, uncovering the secrets of distant galaxies and exoplanets. Together, these missions are expanding our knowledge and paving the way for the next generation of explorers, both robotic and human. In the end, robotic probes are more than just machines. They're our eyes and ears in the cosmos, bringing us closer to understanding the universe and our place within it. And as they continue their journeys into the unknown, they remind us that the spirit of exploration is alive and well, driving us to reach further, dream bigger, and uncover the mysteries that lie beyond the stars. The idea of mining in space might sound like something straight out of a sci-fi movie, but it's rapidly becoming a cornerstone of our plans for exploring and settling beyond Earth. Picture this: robots equipped with drills, scoops, and advanced sensors, working tirelessly on distant asteroids or the surface of the moon, extracting water, metals, and other vital resources. These aren't just machines, they're the future of space sustainability, and they could hold the key to making long-term missions to Mars and beyond not just possible, but practical. So, why is space mining so important? The answer lies in the immense cost and challenge of transporting everything we need from Earth. Every gallon of water, every pound of metal, and every piece of equipment adds weight to a spacecraft, making missions more expensive and complex. But if we can harvest resources directly from space, we can drastically reduce this burden. Water, for example, can be split into hydrogen and oxygen to create rocket fuel, while metals and minerals can be used to build habitats, tools, and even spacecraft. Space mining robots could turn distant worlds into supply depots, enabling us to live and work in space without constant reliance on Earth. One of the most exciting targets for space mining is water ice, which has already been detected on the Moon, Mars, and even some asteroids. Robots designed to extract this ice could revolutionize how we approach space exploration. On the Moon, for instance, mining robots could drill into permanently shadowed craters to harvest ice, which could then be converted into drinking water, oxygen for breathing, or fuel for rockets. This would not only support lunar bases, but also serve as a stepping stone for missions to Mars and beyond. Imagine a lunar outpost where robots work around the clock, gathering resources that fuel humanity's journey into the solar system. Asteroids are another frontier for space mining. These rocky bodies are rich in precious metals like platinum, as well as rare earth elements that are essential for electronics and advanced technologies. Robotic miners could land on these asteroids, using drills and crushers to break apart the rock and extract valuable materials. Some of these resources could be used in space, while others might be sent back to Earth, potentially creating a new industry that transforms how we think about resource extraction. It's a bold vision, but one that's already being explored by companies and space agencies around the world. But space mining isn't just about the resources themselves, it's also about the technology. These robots will need to be incredibly resilient, capable of operating in extreme temperatures, low gravity, and harsh environments. They'll need advanced AI to navigate complex terrain, identify valuable materials, and carry out precise operations without human intervention. And they'll need to be self-sufficient, able to repair themselves and adapt to unexpected challenges. Developing these capabilities isn't just about mining, it's about pushing the boundaries of robotics and AI, creating systems that can thrive in the most demanding conditions imaginable. What makes space mining so transformative is its potential to make space exploration truly sustainable. By using resources found in space, we can reduce our reliance on Earth, making missions cheaper, faster, and more efficient. It's a shift that could open up new possibilities, from building permanent bases on the Moon to establishing self-sustaining colonies on Mars. And as these technologies evolve, they'll not only support space exploration, but also inspire new innovations here on Earth, from advanced robotics to sustainable resource management. Space mining robots are more than just tools, they're the foundation of a new era in space exploration. They represent a future where we're not just visitors to the cosmos, but active participants, shaping our destiny among the stars. And as we take these first steps toward harvesting resources beyond Earth, we're not just solving practical challenges, we're redefining what it means to explore, to innovate, and to dream. When we think about living on Mars or the Moon, the first challenge that comes to mind isn't just getting there, it's building a place to stay. Constructing habitats and infrastructure in the vacuum of space or on the dusty, radiation-baked surface of Mars is no small feat. That's where robotic construction comes in, and it's already proving to be a game changer. Imagine robots that can assemble massive modules, lay foundations, and even 3D print entire structures using materials found right there on site. These aren't just machines, they're the architects and builders of humanity's future in space. One of the most exciting developments in this field is 3D printing using regolith, the loose soil and rock found on the Moon and Mars. Instead of hauling tons of building materials from Earth, robots could use this readily available resource to create everything from walls to landing pads. NASA and other space agencies are already testing this technology with robots that can melt regolith and extrude it into solid, durable structures. It's like turning dirt into bricks, but on a cosmic scale. This approach not only saves time and money, but also reduces the need for resupply missions, making long-term space habitats far more sustainable. But construction robots aren't just about printing, they're also about precision. In space, where every gram of material and every moment of labor is precious, robots can perform tasks with an accuracy that's hard to match. For example, robotic arms equipped with specialized tools can assemble complex modules in orbit, piecing together habitats or spacecraft without the need for human hands. These systems can work tirelessly in environments that would be dangerous or impossible for astronauts, from the airless void of space to the harsh, dusty plains of Mars. The benefits of robotic construction go beyond just efficiency. By automating these tasks, we can significantly reduce the risks to human life. Space is an unforgiving place, and every minute spent outside a habitat or spacecraft increases the danger for astronauts. Robots, on the other hand, can handle the heavy lifting, the repetitive tasks, and the hazardous conditions, allowing humans to focus on more complex and creative aspects of space exploration. It's a partnership that maximizes safety while expanding our capabilities. What's truly remarkable is how these technologies are evolving. Today's construction robots are already impressive, but the next generation will be even more advanced. Imagine swarms of small, autonomous robots working together to build entire habitats, each one specialized for a specific task. Some could gather materials, others could assemble structures, and still others could inspect and repair the work as it progresses. This kind of collaboration isn't just efficient, it's revolutionary, opening up possibilities for construction on a scale we've never seen before, and the implications are enormous. By mastering robotic construction, we're not just preparing for life on Mars or the Moon, we're laying the groundwork for a future where humanity can thrive beyond Earth. These technologies will enable us to build not just habitats, but entire communities, complete with the infrastructure needed to support science, industry, and even tourism. It's a vision that's as ambitious as it is achievable, and it's all thanks to the incredible potential of robotic construction. In the end, these robots are more than just tools. They're the foundation of a new era in space exploration. They're the builders of our dreams, the ones who will turn the barren landscapes of distant worlds into homes for humanity. And as they work tirelessly to create the structures we'll need to survive and thrive, they remind us that the future of space isn't just about reaching new frontiers. It's about building them, one robotic brick at a time. As astronauts venture further into the cosmos, they're not just battling the vast emptiness of space, they're facing a unique set of challenges that test both their physical and mental limits. Microgravity can weaken muscles and bones, isolation can strain mental health, and the sheer complexity of their tasks can be overwhelming. This is where robotic assistants step in, offering a helping hand, or in some cases, a robotic arm, to make life in space not just manageable, but more efficient and even a little more comfortable. Take NASA Robonaut, for example. This humanoid robot isn't just a technological marvel, it's a teammate designed to work alongside astronauts on the International Space Station, performing tasks that range from the mundane to the mission-critical. Robonaut and robots like it are built to handle the kind of work that would be tedious, time-consuming, or outright dangerous for humans. Imagine a robot that can clean air filters, organize supplies, or even conduct experiments with precision, freeing up astronauts to focus on more complex tasks. These robotic assistants aren't just tools, they're partners, capable of operating in environments where humans would need bulky suits or face significant risks. For instance, in the vacuum of space, a robot can perform repairs outside the spacecraft without the need for a spacewalk, reducing the danger and conserving precious time. But the role of robotic assistants goes beyond just physical tasks. Space is an isolating place, and the psychological strain of being millions of miles from Earth can take a toll. Robots designed with advanced AI and even limited conversational capabilities can provide a sense of companionship, helping to alleviate the loneliness that comes with long-term missions. They're not just machines, they're a bridge between the human need for connection and the harsh realities of space exploration. By offering both practical support and emotional comfort, these robots are redefining what it means to be a crew member. As we set our sights on Mars, the importance of robotic assistance will only grow. Longer missions mean more complex challenges, from maintaining equipment over extended periods to managing the psychological well-being of astronauts. Robots will be there every step of the way, ensuring that missions run smoothly and that humans can focus on the bigger picture. They'll handle the repetitive tasks, monitor systems for potential issues, and even assist in emergencies, becoming an integral part of the team. What's truly exciting is how these robots are evolving. Early models like Robonaut were groundbreaking, but the next generation will be even more advanced. Picture robots with enhanced mobility, capable of navigating the uneven terrain of Mars, or AI systems that can predict and solve problems before they arise. These advancements aren't just about improving efficiency, they're about creating a seamless partnership between humans and machines, where each complements the other's strengths. In the end, robotic assistants are more than just a technological innovation. They're a testament to our ability to adapt and thrive in the most challenging environments. They remind us that exploration isn't just about reaching new frontiers, it's about creating the tools and systems that allow us to stay there. And as we prepare for the next chapter of human spaceflight, these robots will be right by our side, proving that the future of space exploration isn't just about humans or machines, it's about the incredible synergy between the two. Picture a group of robots, each no larger than a shoebox, working together seamlessly across the rugged surface of Mars. They're not just individual machines, they're a team communicating, coordinating, and solving problems as one. This is the power of swarm robotics, a cutting-edge approach inspired by nature's most efficient collaborators, ants, bees, and other social insects. In space, where every mission is a delicate balance of time, resources, and precision, swarm robotics offers a revolutionary way to tackle challenges that would overwhelm a single robot. By leveraging collective intelligence, these robots can map uncharted terrain, assemble structures, and even repair equipment faster and more efficiently than ever before. What makes swarm robotics so transformative is its ability to scale. Instead of relying on one highly specialized robot, a swarm can distribute tasks across multiple units, each contributing its unique strengths. For example, while one robot might focus on collecting soil samples, another could analyze the data, and a third could transmit the findings back to Earth. This division of labor isn't just efficient, it's adaptable. If one robot fails, the others can adjust their roles to compensate, ensuring the mission continues without interruption. It's a level of resilience and flexibility that's crucial in the unpredictable environment of space. One of the most exciting applications of swarm robotics is in mapping and exploration. Imagine sending a swarm of robots to a distant asteroid or the surface of a moon. Instead of relying on a single rover to painstakingly chart the area, the swarm can spread out, covering vast distances in a fraction of the time. Each robot would collect data and share it with the group, building a detailed, real-time map of the terrain. This isn't just about speed, it's about creating a comprehensive understanding of the environment, identifying hazards, and pinpointing areas of scientific interest. For future human missions, this kind of information could be the difference between success and disaster. But swarm robotics isn't just about exploration, it's also about construction. In space, where resources are limited and every gram of material counts, swarms of robots could work together to build habitats, landing pads, or even spacecraft. Picture a team of robots 3D printing a structure, with some robots gathering materials, others assembling components, and still others inspecting the work for quality. This kind of collaborative effort would not only save time, but also reduce the risks to human crews, allowing us to establish a presence on other worlds more safely and efficiently. What sets swarm robotics apart is its ability to adapt. These robots aren't just following a pre-programmed script, they're constantly learning from their environment and each other. If a mission encounters unexpected obstacles, the swarm can reconfigure itself to overcome them. For example, if a robot detects a patch of unstable ground, it can alert the others, who can then navigate around it. This kind of real-time problem solving is invaluable in space, where conditions can change in an instant and there's no room for error. The potential of swarm robotics goes far beyond what we've already imagined. As these technologies evolve, they could enable entirely new approaches to space exploration. Imagine swarms of robots working together to mine asteroids, repair satellites, or even terraform distant planets. These aren't just dreams, they're possibilities that swarm robotics could make real. By combining the power of collective intelligence with the precision of modern robotics, we're opening up a new frontier in how we explore and interact with the cosmos. At its core, swarm robotics is about more than just technology. It's about collaboration. These robots remind us that some of the greatest achievements come not from individual effort, but from working together. And as we look to the stars, they show us that the future of space exploration isn't just about going further, it's about going smarter, with robots and humans working side by side to unlock the mysteries of the universe. Imagine a spacecraft hurtling through the void of space, millions of miles from Earth. Over time, its components begin to degrade, solar panels lose efficiency, fuel lines develop leaks, and critical systems falter. In the harsh environment of space, where every piece of equipment is pushed to its limits, wear and tear are inevitable. But here's the catch: sending a repair crew from Earth isn't just impractical, it's often impossible. This is where robotic repair and maintenance systems come into play, stepping in as the ultimate space mechanics to keep our missions alive and thriving. Robots designed for repair and maintenance are nothing short of engineering marvels. Equipped with advanced tools, precision instruments, and cutting-edge AI, they can tackle tasks that would be too risky or complex for human astronauts. Take NASA, a robotic refueling mission, for example. This groundbreaking project showcased how robots could refuel satellites in orbit, a task once thought to be impossible. Using a robotic arm and specialized tools, the mission successfully demonstrated that satellites could be serviced and extended beyond their original lifespans. It was a game changer, proving that robots could not only fix problems, but also breathe new life into aging spacecraft. What makes these robotic repair systems so indispensable is their ability to work in environments that are outright hostile to humans. Space is a vacuum, with extreme temperatures, radiation, and microgravity conditions that make even the simplest repairs a monumental challenge. Robots, however, can operate in these conditions with ease. Whether it's replacing a damaged solar panel, sealing a fuel leak, or recalibrating a malfunctioning instrument, they perform these tasks with precision and reliability, ensuring that critical systems remain operational. But it's not just about fixing things when they break. Robotic maintenance systems are also proactive, designed to monitor equipment and detect potential issues before they escalate. Using sensors and AI, these robots can analyze data in real time, identifying signs of wear or malfunction and addressing them before they become serious problems. This predictive capability is crucial for long-term missions, where a single failure could jeopardize the entire endeavor. By keeping spacecraft and habitats in top condition, robotic repair systems are the unsung heroes of space exploration, working tirelessly behind the scenes to ensure mission success. As we set our sights on Mars and beyond, the role of robotic repair will only grow more critical. Longer missions mean more opportunities for equipment to fail, and the farther we travel from Earth, the harder it becomes to send replacement parts or repair crews. Robotic systems will need to be even more autonomous, capable of diagnosing and fixing problems without human intervention. Imagine a future where robots on Mars can repair habitats, service rovers, or even assemble new structures using locally sourced materials. These capabilities will be essential for establishing a sustainable presence on other worlds, turning what was once science fiction into reality. What's truly remarkable about these robotic repair systems is how they embody the spirit of innovation. They're not just tools, they're problem solvers designed to overcome the unique challenges of space exploration. By combining advanced technology with human ingenuity, they're redefining what's possible, ensuring that our missions can continue even in the face of adversity. And as we push the boundaries of exploration, these robots will be there every step of the way, proving that the future of space isn't just about reaching new frontiers, it's about maintaining them, one repair at a time. As we push further into the cosmos, one of the greatest challenges we face isn't just distance, it's time. Communicating across the vast expanse of space isn't like sending a text message. It's a delicate dance of signals that can take minutes or even hours to travel between planets. For missions to Mars and beyond, this delay isn't just inconvenient, it's a critical hurdle that could mean the difference between success and failure. That's where robotic communication systems come into play, acting as the vital link that bridges the gap between Earth and the farthest reaches of our exploration. At the heart of these systems is a network of advanced technologies designed to handle the unique demands of interplanetary communication. High-gain antennas, for example, act like cosmic megaphones, amplifying signals to ensure they can travel millions of miles without losing clarity. These antennas are paired with powerful transmitters and receivers, capable of sending and decoding data at incredible speeds. But it's not just about the hardware. Robotic communication systems also rely on sophisticated software that can compress and prioritize data, ensuring that the most critical information gets through first, even when bandwidth is limited. One of the most remarkable aspects of these systems is their ability to enable real-time collaboration between humans and robots, despite the staggering distances involved. Take the Mars rovers, for instance. While it can take up to 20 minutes for a signal to travel from Earth to Mars, the rovers are equipped with AI that allows them to operate semi-autonomously. They can receive a set of instructions, analyze their surroundings, and make decisions on the fly, all while keeping mission control updated with a steady stream of data. This blend of human oversight and robotic independence is what makes modern space exploration so effective. But robotic communication isn't just about sending commands. It's also about bringing us closer to the places we're exploring. Every image of a Martian sunset, every measurement of a distant asteroid, and every analysis of a planetary atmosphere is relayed back to Earth through these systems. They're our window into the cosmos, allowing us to see and understand worlds that are otherwise out of reach. And as these technologies evolve, they're becoming even more powerful. Laser communication systems, for example, are being tested as a faster, more efficient alternative to traditional radio waves, promising to revolutionize how we share information across the solar system. What's truly exciting is how these communication systems are enabling new kinds of missions. Imagine a future where swarms of robots on Mars work together under the guidance of scientists on Earth, exploring vast landscapes and conducting experiments in real time. Or think about the possibilities for deep space probes, which could send back data from the edges of our solar system in near real time, thanks to advances in communication technology. These systems aren't just tools, they're the foundation of a new era of exploration, where humans and robots work together seamlessly, no matter how far apart they are. The challenges of interplanetary communication are immense, but so are the opportunities. By developing technologies that can overcome these hurdles, we're not just solving a technical problem, we're creating the infrastructure for humanity's future in space. Whether it's enabling astronauts to communicate with mission control from Mars, or allowing robots to share their discoveries with scientists on Earth, these systems are the threads that connect us to the stars. And as we continue to push the boundaries of what's possible, they remind us that the journey to explore the cosmos isn't just about reaching new frontiers, it's about staying connected every step of the way. The universe is a place of extremes, places so harsh and unforgiving that they seem almost designed to keep us out. From the icy, sub-zero oceans beneath Europa's frozen crust to the blistering, sulfuric acid-laden atmosphere of Venus, these environments push the limits of what life, and even machines, can endure. Yet, it's precisely these extreme conditions that hold some of the most tantalizing secrets of our solar system. And while humans may never set foot in these hostile worlds, robotics are stepping in to explore where we cannot, unlocking mysteries that could reshape our understanding of the cosmos. Take Europa, one of Jupiter's moons, for example. Beneath its icy surface lies a vast, global ocean that could hold more than twice the water found on Earth. This makes it one of the most promising places to search for extraterrestrial life. But how do you explore an ocean buried under miles of ice? Enter robotic submarines, or cryobots, designed to melt through the icy crust and navigate the dark, frigid waters below. These machines are built to withstand crushing pressures and freezing temperatures, while carrying sensitive instruments to analyze the water for signs of life. It's a mission that would be impossible for humans, but with robotics, we're on the verge of uncovering what lies beneath Europa's icy shell, On the opposite end of the spectrum lies Venus, a planet often described as Earth's evil twin. With surface temperatures hot enough to melt lead and an atmosphere thick with sulfuric acid, Venus is one of the most inhospitable places in the solar system. Yet, robotic explorers are being designed to survive and even thrive in these hellish conditions. For instance, NASA's, a proposed Venus rover designed to withstand the planet's extreme heat and pressure, could study its volcanic activity and geology, providing clues about how Venus evolved into such a hostile environment. These robots aren't just exploring, they're helping us understand the delicate balance that makes Earth so uniquely habitable. But it's not just about surviving extreme environments, it's about adapting to them. Robots exploring these worlds are equipped with cutting-edge technology, from advanced thermal shielding to AI-driven navigation systems. On Europa, a cryobot might use sonar to map the ocean floor, while on Venus, a rover could deploy instruments to analyze the chemical composition of the atmosphere. Each mission is tailored to the unique challenges of its environment, showcasing the incredible versatility of robotic exploration. What makes these missions so groundbreaking is their potential to answer some of humanity's biggest questions. Could life exist beneath Europa's icy surface? What caused Venus to become such a hostile world? And what can these extreme environments teach us about the limits of life itself? By sending robots to explore these frontiers, we're not just expanding our reach, we're expanding our understanding of the universe and our place within it. As we continue to push the boundaries of exploration, robotics are proving to be more than just tools. They're our proxies, venturing into places we can only dream of reaching. They're the pioneers of the cosmos, braving the harshest conditions to bring back knowledge that could one day change everything. And as they journey into these extreme environments, they remind us that the universe is full of wonders waiting to be discovered, if only we have the courage and the technology to seek them out. High above the Earth, far beyond the reach of human hands, robotic telescopes are silently reshaping our understanding of the universe. These incredible instruments, like the Hubble Space Telescope, have become our eyes in the cosmos, peering into the depths of space with a clarity and precision that was once unimaginable. From capturing the birth of stars in distant galaxies to spotting planets orbiting other suns, robotic telescopes are uncovering secrets that were hidden for billions of years. And the best part, they're doing it all on their own, tirelessly scanning the skies night after night, collecting data that's rewriting the textbooks of astronomy. One of the most remarkable things about robotic telescopes is their ability to operate autonomously. Unlike traditional telescopes, which require constant human oversight, these machines can be programmed to observe specific targets, adjust their focus, and even respond to changes in the environment, all without a single person lifting a finger. This level of automation isn't just convenient, it's revolutionary. It allows scientists to gather data on a scale that would be impossible with manual observation, opening up entirely new avenues of research. For example, robotic telescopes can monitor thousands of stars simultaneously, searching for the telltale dimming that signals a planet passing in front of its host star. It's a level of efficiency that's transforming how we discover and study exoplanets. But robotic telescopes aren't just about quantity, they're about quality too. Equipped with cutting-edge optics and advanced imaging systems, these instruments can capture details that were once beyond our reach. Take the Hubble Space Telescope, for instance. Its iconic images of nebulae, galaxies, and star clusters aren't just breathtaking, they're packed with scientific insights. By analyzing the light from distant objects, Hubble has helped us measure the expansion of the universe, uncover the presence of dark energy, and even study the atmospheres of planets outside our solar system. And while Hubble is perhaps the most famous, it's far from alone. Telescopes like the James Webb Space Telescope, set to launch in the near future, promise to push these capabilities even further, peering deeper into space and further back in time than ever before. What makes robotic telescopes so powerful is their ability to work around the clock. While human observers are limited by geography, weather, and the simple fact that they need to sleep, robotic telescopes can operate continuously, capturing data from every corner of the sky. This constant vigilance is especially crucial for studying transient events like supernova or gamma-ray bursts, which can appear and vanish in the blink of an eye. By automatically detecting and responding to these events, robotic telescopes ensure that no cosmic phenomenon goes unnoticed, giving scientists the chance to study them in unprecedented detail. And the impact of these discoveries goes far beyond astronomy. The data collected by robotic telescopes is helping us answer some of the biggest questions in science. How did the universe begin? Are we alone in the cosmos? What is the fate of our galaxy? These are questions that have fascinated humanity for centuries, and now, thanks to robotic telescopes, we're closer than ever to finding the answers. Each new discovery brings us a step closer to understanding our place in the universe, inspiring not just scientists, but dreamers, artists, and explorers around the world. As we look to the future, robotic telescopes will continue to play a vital role in our exploration of the cosmos. They'll help us map the universe in greater detail, study the formation of galaxies, and even search for signs of life on distant worlds. And as these technologies evolve, they'll open up new possibilities for discovery, from building telescopes on the moon to launching fleets of space-based observatories. The universe is vast, mysterious, and full of wonders waiting to be uncovered, and with robotic telescopes as our guides, there's no limit to what we might find. Robotic spacecraft are the unsung heroes of space exploration, tirelessly venturing into the farthest reaches of our solar system to uncover secrets that would otherwise remain hidden. Take Cassini, for instance, a mission that spent 13 years orbiting Saturn, capturing breathtaking images of its rings, moons, and storms, or Juno, which has been circling Jupiter, peeling back the layers of its thick atmosphere to reveal the planet's inner workings. These robotic explorers are more than just machines. They're our eyes and ears in the cosmos, equipped with cutting-edge instruments that allow us to study distant worlds in unprecedented detail. What makes these spacecraft so extraordinary is their ability to carry out complex scientific missions with precision and autonomy. Cassini, for example, carried a suite of instruments designed to measure magnetic fields, analyze atmospheric compositions, and even detect organic molecules on Saturn's moon, Enceladus. Its discoveries were nothing short of revolutionary, from the geysers of water ice erupting from Enceladus to the intricate dynamics of Saturn's rings. Similarly, Juno has been mapping Jupiter's magnetic field and studying its turbulent storms, providing clues about the planet's formation and evolution. These missions aren't just about collecting data, they're about piecing together the story of our solar system. One of the most remarkable aspects of robotic spacecraft is their ability to operate in environments that would be impossible for humans. The intense radiation around Jupiter, for example, is so severe that it would quickly overwhelm any human-made electronics, yet Juno's instruments are shielded to withstand these conditions, allowing it to gather critical data. Cassini, on the other hand, navigated the delicate gravitational dance between Saturn and its moons, using their gravity to adjust its orbit and extend its mission. These spacecraft are engineering marvels, designed to survive and thrive in some of the harshest environments imaginable, but the impact of these missions goes far beyond the planets they study. By analyzing the atmospheres, magnetic fields, and geological features of distant worlds, robotic spacecraft are helping us understand the fundamental processes that shaped our solar system. For instance, Cassini's discovery of liquid water beneath Enceladus' icy surface has profound implications for the search for extraterrestrial life. Similarly, Juno's insights into Jupiter's core are reshaping our theories about how gas giants form. These missions are like time machines, allowing us to peer back billions of years to the dawn of our solar system. What's truly inspiring about robotic spacecraft is how they bring distant worlds to life. Through their cameras and sensors, we've seen the swirling storms of Jupiter, the ethereal beauty of Saturn's rings, and the rugged landscapes of moons that might harbor life. These images and data don't just belong to scientists, they belong to everyone, inspiring wonder and curiosity in people around the world. They remind us that the universe is vast, mysterious, and full of possibilities, waiting to be explored. As we look to the future, robotic spacecraft will continue to play a vital role in our exploration of the cosmos. Missions like Europa Clipper, set to launch in the coming years, will search for signs of life beneath the icy crust of Jupiter's moon Europa. Others, like the Dragonfly mission to Saturn's moon Titan, will study its methane lakes and organic-rich atmosphere, offering clues about the origins of life. These missions are more than just scientific endeavors, they're a testament to our curiosity and determination to understand the universe. In the end, robotic spacecraft are more than just tools. They're our partners in discovery, pushing the boundaries of what we know and inspiring us to dream bigger. They remind us that exploration isn't just about reaching new frontiers, it's about uncovering the stories of the cosmos and our place within it. And as they continue their journeys, they're showing us that the universe is far more fascinating and far more accessible than we ever imagined. Imagine stepping into a habitat on Mars, a place where every wall, every piece of equipment, and even the air you breathe has been meticulously designed and maintained, not by human hands, but by robots. Creating sustainable living spaces on other worlds is one of the greatest challenges we face as we prepare for long-term space exploration. And while the idea of building a home on Mars might seem like science fiction, robotics are already proving to be the key to turning this vision into reality. From 3D printing habitats to managing life support systems, robots are not just assisting in this effort, they're leading the charge. One of the most groundbreaking advancements in this area is the use of 3D printing to construct habitats using materials found right on site. Instead of hauling tons of building supplies from Earth, robots can use regolith, the loose soil and rock covering Mars and the Moon, to create durable, sustainable structures. NASA and other space agencies have already tested this technology, with robots that can melt regolith and extrude it into solid walls, floors, and even roofs. It's like turning dirt into bricks, but on a cosmic scale. This approach not only saves time and money, but also reduces the need for resupply missions, making long-term habitation far more feasible. But construction is just the beginning. Once habitats are built, robots will play a vital role in maintaining them. Think about the challenges of living on Mars: extreme temperatures, radiation, and a lack of breathable air. Robots will be tasked with monitoring and repairing critical systems, from air filtration to temperature control, ensuring that these habitats remain safe and functional. For example, autonomous robots could inspect and repair solar panels damaged by dust storms, or recalibrate life support systems to optimize oxygen levels. These tasks, while routine, are absolutely essential for survival in such a hostile environment. What makes robotic habitats so revolutionary is their potential for self-sufficiency. Robots could be programmed to manage everything from water recycling to food production, creating closed-loop systems that minimize waste and maximize efficiency. Imagine a greenhouse on Mars, tended by robots that monitor soil conditions, adjust lighting, and even harvest crops. These systems wouldn't just support human life, they'd create a sustainable ecosystem, capable of sustaining itself over long periods without constant input from Earth. And the benefits extend beyond just survival. Robotic habitats could also enhance the quality of life for astronauts, making their living spaces more comfortable and functional. Robots could handle mundane tasks like cleaning, organizing supplies, and even providing companionship during long missions. This would free up astronauts to focus on scientific research, exploration, and other high-priority activities, making their time in space more productive and fulfilling. As we look to the future, the role of robotic habitats will only grow more critical. longer missions to Mars and beyond will require habitats that can adapt and evolve over time, supporting not just survival, but thriving in the harshest conditions imaginable. Robots will be at the heart of this effort, ensuring that these habitats are not just livable, but sustainable, efficient, and even inspiring. They're not just building structures, they're building the foundation for humanity's future in space. In the end, robotic habitats are more than just a technological innovation. They're a testament to our ability to adapt and thrive in the most challenging environments. They remind us that the future of space exploration isn't just about reaching new frontiers. It's about creating the tools and systems that allow us to stay there. And as we take these first steps toward building homes on other worlds, we're not just solving practical challenges, we're redefining what it means to explore, to innovate, and to dream. Imagine a future where astronauts on Mars sit down to a meal of fresh vegetables, grown not on Earth, but right there on the red planet. It might sound like something out of a sci-fi movie, but with robotic agriculture, this vision is closer to reality than ever before. Growing food in space isn't just about convenience, it's a necessity for long-term missions. And while humans have been farming for thousands of years, the challenges of space demand a new kind of farmer, robots. These mechanical growers are revolutionizing how we think about agriculture, turning barren environments into thriving gardens and ensuring that astronauts have the nourishment they need to explore the cosmos. At the heart of robotic agriculture is the ability to automate every step of the growing process. Robots can monitor plant health with sensors that track everything from soil moisture to nutrient levels, ensuring that crops get exactly what they need to thrive. They can adjust lighting, temperature, and humidity to create the perfect growing conditions, even in the harsh environment of space. And when it's time to harvest, robotic arms can carefully pick fruits and vegetables with precision, minimizing waste and maximizing yield. This level of automation isn't just efficient, it's essential for missions where every resource counts. One of the most exciting aspects of robotic farming is its potential to create closed-loop systems. Instead of relying on resupply missions to deliver food, astronauts could grow their own, recycling water and nutrients to create a self-sustaining ecosystem. Picture a greenhouse on Mars, where robots tend to rows of leafy greens, tomatoes, and herbs, all while recycling waste into compost and filtering water for reuse. This kind of system wouldn't just provide fresh food, it would also reduce the need for costly and risky resupply missions, making long-term space exploration far more sustainable. But robotic agriculture isn't just about practicality, it's also about improving the quality of life for astronauts. Fresh food isn't just nutritious, it's a morale booster, a taste of home in the vast emptiness of space. Imagine the psychological benefits of tending to a garden, even if it's with the help of robots. Studies have shown that growing plants can reduce stress and improve mental well-being, and in the isolating environment of space, this could be a game changer. By combining the science of agriculture with the art of living, robotic farming is redefining what it means to thrive beyond Earth. What makes robotic agriculture so transformative is its adaptability. These systems aren't just designed for Mars, they could be used on the Moon, in deep space habitats, or even on Earth in extreme environments like deserts or polar regions. The technology being developed for space farming could have far-reaching applications, from addressing food shortages to creating more sustainable agricultural practices. It's a reminder that the challenges of space exploration often lead to innovations that benefit us all. As we prepare for the next chapter of human spaceflight, robotic agriculture is proving to be more than just a tool, it's a cornerstone of our future in space. By automating the growing process, these robots are ensuring that astronauts have the resources they need to explore, discover, and thrive. And as we take these first steps toward farming in the cosmos, we're not just growing food, we're cultivating the seeds of a new era in space exploration, where sustainability and innovation go hand in hand. Imagine floating in the vast expanse of space, millions of miles from Earth, where even a minor health issue could escalate into a life-threatening situation. This is the reality astronauts face every day, where the unique challenges of space, like radiation, microgravity, and isolation, take a toll on the human body. But what if there was a way to keep a constant, vigilant eye on their health, spotting potential problems before they become critical? Enter robotic health monitoring systems, the unsung guardians of astronaut well-being. These advanced machines, equipped with cutting-edge sensors and artificial intelligence, are transforming how we care for astronauts, ensuring they stay healthy and safe on long missions to Mars and beyond. At the core of these systems is the ability to monitor vital signs in real time. Robots can track everything from heart rate and blood pressure to oxygen levels and even hydration status, providing a comprehensive picture of an astronaut's health. This isn't just about collecting data, it's about detecting subtle changes that might indicate a problem. For example, a slight dip in oxygen levels could signal a leak in the habitat, while irregular heart rhythms might point to the early stages of a medical condition. By catching these issues early, robotic systems can alert astronauts and mission control, allowing them to take action before the situation worsens. But robotic health monitoring goes beyond just tracking numbers. These systems are designed to understand context, using AI to analyze patterns and predict potential risks. Imagine a robot that notices an astronaut's muscle mass is declining faster than expected due to the effects of microgravity. It could recommend specific exercises or adjust the crew's diet to counteract the loss, or consider a scenario where a robot detects elevated radiation levels and automatically activates shielding protocols to protect the crew. This level of proactive care is what sets robotic health monitoring apart, turning reactive problem-solving into preventative maintenance. One of the most groundbreaking aspects of these systems is their potential to provide medical assistance. In space, where every second counts, robots equipped with medical tools and AI-driven diagnostics could perform life-saving procedures. Picture a robot that can administer injections, stitch wounds, or even assist in surgery, guided by real-time data and remote instructions from doctors on Earth. These capabilities aren't just hypothetical, they're being developed and tested, bringing us closer to a future where astronauts have access to high-quality medical care, no matter how far they are from home. What makes robotic health monitoring so transformative is its ability to adapt to the unique challenges of space. On Earth, we take for granted the ability to visit a doctor or access medical facilities. In space, these luxuries don't exist, and the stakes are infinitely higher. Robots bridge this gap, offering a level of care that's tailored to the demands of space travel. They're not just tools, they're partners, working alongside astronauts to ensure their well-being and mission success. As we prepare for the next chapter of human spaceflight, robotic health monitoring will play a pivotal role in safeguarding astronauts on their journey to Mars and beyond. These systems are more than just technological marvels, they're a testament to our commitment to exploration, ensuring that we can push the boundaries of what's possible without compromising the health and safety of those who venture into the unknown. And as these technologies continue to evolve, they'll not only protect astronauts, but also pave the way for a future where humanity can thrive in the harshest environments imaginable. Picture an astronaut floating outside a spacecraft, tethered to nothing but the infinite void of space. Every movement is deliberate, every task a delicate balance of precision and caution. Spacewalks are among the most dangerous and demanding aspects of space exploration, requiring astronauts to navigate an environment where even the smallest mistake can have catastrophic consequences. Traditional spacesuits, while essential for survival, are bulky and restrictive, often limiting mobility and making even simple tasks a challenge. But what if spacesuits could do more than just protect astronauts? What if they could enhance their capabilities, giving them the strength and flexibility to work more efficiently and safely? This is where robotic spacesuits come in, blending cutting-edge technology with human ingenuity to revolutionize extravehicular activities. At the heart of these robotic suits is the concept of the exoskeleton, a framework of mechanical limbs and joints that work in harmony with the astronaut's movements. Imagine a suit that not only protects you from the vacuum of space, but also amplifies your strength, allowing you to lift heavy equipment or maneuver tools with ease. These exoskeletons are designed to reduce fatigue, providing support to muscles and joints during prolonged spacewalks. For instance, a robotic suit could take on the bulk of the effort when tightening a bolt or adjusting a solar panel, leaving the astronaut free to focus on precision and control. It's like having a mechanical partner built right into your suit, working seamlessly to enhance your capabilities. But the benefits of robotic space suits go beyond just strength and support. Advanced materials and actuators embedded in the suit can improve mobility, allowing for more natural and fluid movements. Traditional space suits can feel stiff and cumbersome, but robotic suits use flexible materials and responsive systems to mimic the body's natural range of motion. This means astronauts can bend, twist, and reach with greater ease, making tasks like repairing equipment or conducting experiments far less taxing. The result is not just greater efficiency, but also reduced risk of injury, as the suit helps maintain proper posture and alignment in the weightless environment of space. One of the most exciting aspects of these suits is their ability to adapt to the unique challenges of spacewalks. For example, robotic suits can be equipped with sensors that monitor the astronaut's vital signs, alerting them to potential issues like overheating or oxygen depletion. They can also provide real-time feedback on movement, helping astronauts avoid awkward or dangerous positions. In emergency situations, the suit could even assist with rapid re-entry into the spacecraft, using its mechanical systems to stabilize and guide the astronaut. These features aren't just about convenience, they're about safety, ensuring that every spacewalk is as secure as possible. As we look to the future, robotic spacesuits will play a critical role in enabling more ambitious missions, from constructing lunar bases to exploring the surface of Mars. The added strength and mobility they provide will allow astronauts to take on more complex tasks, from assembling large structures to conducting detailed scientific research. And as these technologies evolve, they'll become even more integrated with the astronaut's body and mind, creating a seamless partnership between human and machine. This isn't just about improving spacesuits, it's about redefining what's possible in space exploration. Robotic spacesuits are more than just tools. They're a testament to our ability to innovate and adapt in the face of incredible challenges. By enhancing mobility, providing support, and ensuring safety, these suits are empowering astronauts to push the boundaries of exploration further than ever before. And as we continue to develop these technologies, they'll not only transform how we work in space, but also inspire us to dream bigger, reaching for the stars with confidence and capability. Picture a space station orbiting high above Earth, bustling with activity, but not the kind you might expect. Instead of astronauts floating through the halls, you'd see robotic arms assembling equipment, AI systems monitoring life support, and autonomous drones conducting experiments. This isn't the International Space Station as we know it. This is the future of orbital habitats, fully robotic space stations. These autonomous hubs could revolutionize how we live and work in space, serving as launch pads for missions to Mars and beyond, while redefining the very concept of a space station. One of the most compelling aspects of robotic space stations is their ability to operate independently. Unlike traditional stations, which require constant human oversight, these futuristic habitats would rely on advanced AI and robotics to manage everything from power systems to scientific experiments. Imagine a station where solar panels are automatically repaired by robotic arms, air filters are monitored and replaced by drones, and experiments are conducted and analyzed by AI. This level of autonomy isn't just convenient, it's transformative, allowing us to conduct research and maintain infrastructure without the need for constant human presence. It's like having a self-sustaining laboratory in orbit, capable of running itself while we focus on the bigger picture. But the benefits of robotic space stations go beyond just efficiency. By reducing the need for human crews, these stations could operate in more extreme environments, such as high radiation zones or deep space orbits, where sending humans would be too risky. They could also serve as critical waypoints for missions to Mars and beyond, providing a place to refuel, resupply, and even repair spacecraft. Picture a robotic station orbiting the Moon, acting as a staging ground for lunar exploration or a testing site for technologies needed for Mars missions. These stations wouldn't just support exploration, they'd accelerate it, creating a network of outposts that extend humanity's reach into the solar system. Another game-changing feature of robotic stations is their potential for scalability. Traditional space stations are limited by the need to accommodate human life support systems, which take up space and resources. Robotic stations, on the other hand, could be designed purely for functionality, with modular components that can be added or removed as needed. This flexibility would allow them to grow and adapt over time, evolving from small research platforms to massive hubs capable of supporting entire fleets of spacecraft. It's a vision of space infrastructure that's not just sustainable but dynamic, capable of meeting the ever-changing demands of exploration. What makes these stations so exciting is their potential to democratize space. With lower operating costs and fewer risks to human life, robotic stations could open up new opportunities for research and industry, making space more accessible to countries, companies, and even universities. Imagine a university launching its own experiments on a robotic station, or a startup testing new technologies in microgravity. These stations could become engines of innovation, fostering collaboration and discovery on a global scale. Of course, the development of robotic space stations isn't without challenges. Building systems that can operate autonomously in the harsh environment of space requires cutting-edge technology, from AI that can make split-second decisions to robotics that can perform delicate repairs. But the progress we've already made, think of the Canadarm2 or the autonomous systems on the ISS, shows that these challenges are not insurmountable. With each breakthrough, we're inching closer to a future where robotic stations are a cornerstone of space exploration. Robotic space stations represent more than just a technological leap. They're a shift in how we think about living and working in space. They're not just tools, they're partners, enabling us to push the boundaries of what's possible. And as we continue to develop these technologies, they'll remind us that the future of space exploration isn't just about reaching new frontiers. It's about creating the systems and infrastructure that allow us to thrive there. With robotic stations leading the way, the possibilities are as vast as the cosmos itself. As robots become increasingly integral to space exploration, a new frontier of ethical questions emerges, one that challenges us to think deeply about the role of these machines in shaping humanity's future among the stars. It's not just about what robots can do, it's about what they should do. Should a robot be allowed to make life or death decisions during a mission? How do we ensure its actions reflect human values, even when operating millions of miles from Earth? These aren't just hypothetical scenarios, they're pressing questions that demand thoughtful answers as we prepare for the next era of human spaceflight. One of the most complex ethical dilemmas centers on autonomy. Giving robots the ability to make decisions independently can be a game changer, especially when communication delays make real-time human oversight impossible. Imagine a Mars rover encountering an unexpected obstacle, a steep cliff or a sudden dust storm. If it waits for instructions from Earth, the delay could cost precious time or even jeopardize the mission. But if the rover acts on its own, how do we ensure it makes the right choice? Striking this balance between autonomy and control is crucial, requiring careful programming and a deep understanding of the ethical principles that guide human decision-making. Another critical consideration is accountability. If a robot makes a mistake, say, damaging a piece of equipment or even endangering a human life, who is responsible? Is it the engineers who designed the system, the programmers who wrote its algorithms, or the mission controllers who oversee its operations? These questions don't have easy answers, but they highlight the need for clear guidelines and protocols as robots take on more complex roles. After all, space exploration is a human endeavor, and the consequences of robotic actions ultimately fall on us. Then there's the question of alignment with human values. Robots operate based on algorithms and data, but these systems must be designed to reflect the ethical priorities of the people who create them. For instance, if a robot is tasked with allocating limited resources during a mission, how should it prioritize between scientific research, crew safety, and mission objectives? These decisions require more than just technical expertise. They demand a nuanced understanding of ethics, ensuring that robots act in ways that align with our collective goals and values. What makes these challenges so profound is their universality. The ethical considerations of robotics in space aren't just about technology, they're about humanity. They force us to confront fundamental questions about our relationship with machines, our responsibilities as creators, and the values we want to carry with us as we explore the cosmos. And as robots become more advanced, these questions will only grow more complex, shaping not just the future of space exploration, but also our understanding of what it means to be human. As we continue to push the boundaries of what's possible, it's clear that robotics will play an increasingly vital role in human spaceflight. But with this role comes a responsibility to develop these technologies thoughtfully and ethically. By addressing these questions head-on, we can ensure that robots are not just tools, but partners in our journey to the stars, partners that reflect the best of who we are and what we hope to achieve. In doing so, we're not just exploring space, we're defining the values that will guide us as we reach for the stars. The journey to Mars and beyond represents one of humanity's most ambitious and inspiring endeavors, a testament to our curiosity, ingenuity, and determination to explore the unknown. At the heart of this monumental challenge lies a powerful ally, robotics. These marvels of engineering have become the unsung heroes of space exploration, transforming the way we approach the cosmos. From autonomous rovers traversing the rugged terrain of Mars to AI-driven systems solving complex problems millions of miles from Earth, robots are not just tools, they're partners in our quest to reach the stars. What makes this collaboration so extraordinary is the way it amplifies human potential. Robots are tackling tasks that are too dangerous, too time-consuming, or simply impossible for us to do alone. They're building habitats, mining resources, and even monitoring the health of astronauts, ensuring that every mission is not just successful, but sustainable. It's a synergy that goes beyond mere technology. It's a partnership that combines the creativity and adaptability of humans with the precision and resilience of machines. Together, we're pushing the boundaries of what's possible, turning the dream of interplanetary exploration into a tangible reality. As we look to the future, the role of robotics will only grow more critical. Whether it's constructing lunar bases, exploring the icy oceans of Europa, or preparing the way for human colonies on Mars, robots will be there every step of the way. They'll help us overcome the challenges of distance, harsh environments, and resource limitations, ensuring that humanity's journey into space is not just a fleeting adventure, but a lasting legacy. And as we continue to innovate, the lessons we learn from these machines will ripple far beyond space exploration, inspiring breakthroughs in science, technology, and even our understanding of ourselves. Thank you for joining us on this journey through the incredible ways robotics are shaping the future of space exploration. If you've enjoyed this deep dive into the technologies paving the way for humanity's next giant leap, don't forget to hit that like button, subscribe for more content, and share your thoughts in the comments below. What excites you most about the future of robotics in space? Let's keep the conversation going as we reach for the stars together. Until next time, stay curious, stay inspired, and remember, the cosmos is waiting.